I've done this a few times and I never do it the same way because people come from different things. So first of all, how many here knows of Gentoo or Portage? No, as in no, they exist.
Oh, they exist.
Okay, keep your hands up. Okay. Using Gentoo. Writing e-builds. Sometimes. Okay. There we go. Okay. Today's presentation I'm gonna show you a little about Portage, the package system in Gentoo, and as any good system, before you start actually hacking away doing your own stuff, you have to know a little about what's going on. So there will be some short presentation of what the system does just to the user. So there. First, these slides are not as good as they could have been. On the other hand, I have not put any kind of license on it, so if you in any way can make this closed source and make money of it, be my guest. Okay, why even considering using a package system? Of course, this is kind of obvious for most people, but in this I also mean, why do you want to make your own packages? And why do you want to use Portage? Well, first of all, Portage is a little different from many other systems in the case that it is a meta-package system. What does that mean? Well, it means that the packages in Portage are not exactly containing the software itself. It just contains information of how to install the software. And this gives some advantages. The first one, it's compatible with other licenses. While Portage and the packages themselves are GPL, the software you install with it does not have to be. So you can also use this package system for commercial software. Actually, in the official package tree of Gentoo, there are several games where you have to have the CD from somewhere else. Another obscure example is when you install Sun Java. Sun requires that you personally download the software from their website because you have to accept a license. Portage can handle that too.
Or also VMware is another example of a paid-for program that exists in Portage.
Yeah. Now, other thing, Portage is lightweight. Yeah. Used to be lightweight, but it's lightweight in the sense that people creating Portage try to keep it with as few dependencies as possible. And of course, when you run Portage on Gentoo Linux, you use a lot of tools because you are a known Linux platform, but the core system itself does not have all these dependencies, which means that you can actually move this system to other platforms. One of the prime examples is that someone, they must have been crazy, has actually moved Portage to OS X, Mac OS X. So now you can run Portage on your Mac and install software with that. And they also make a nice GUI.
All the BSDs and even Solaris, their Portage will run well on these.
Yeah.
Not easily, but.
What it would like. Yeah. Now, here's from the user point of view. Portage keeps track of dependencies. This is a pain in the ass for anyone who doesn't have a package system. Of course, you expect a modern package system to handle this. But when you install something, you do not want to keep track of all the libraries and stuff you need for one particular piece of software. You want the system to handle this automatically. And in case of writing your own packages for Portage, it means that you can rely on existing packages. This is nice if you want to give this package to someone else so they can easily install it. Portage support virtual dependencies, which means that a dependency can be not just on a specific piece of software, but also it could be on, well, some virtual, what should we say?
Like mailer?
Yeah, it would require a mailer client, but it does not require a specific one. But any mailer that can actually, or mailer server for that, that actually gives that virtual dependency, it can use. Another example is that an application might need OpenGL, but does not care whether it's Mesa or from X or from whatever. Portage keeps track of what it installs. This might seem kind of obvious, but the idea is it keeps track of the individual files. It keeps track of dates, and for each file it installs, it also has the MD5 checksum. This means that Portage can install something that most package systems can do today, but it has been a pain in the ass before. But it also means that you can actually, in your live file system, find out a certain file, who owns it. It means you can find out, has anyone changed anything? And this can be very useful. Portage support per package configuration, meaning that, of course, you have some kind of configuration of how you want to set up your system, but you can also change this per package. I'll come into this a bit later. Portage support overlays. This is very useful, especially for, in this case, you want to build your own packages, meaning that you have several package trees as overlays, and the whole system sees kind of the sum of all this. This is also very useful when you want to just make your own package because you want to add a patch to some software. Again, we'll see this. And Portage support code reuse. This you will not get until you see it. Okay. Why not to use Portage? Portage is source-based. The reason why I listed here is because this is one of the many reoccurring flame wars that whenever people discuss what should happen in Portage, I think every other month there will start a new thread about whether or not it's a good idea it's source-based. And usually someone goes like, oh, we want binary packages because we want to distribute it to a lot of machines. And then you have like 1,000 mails going back and forth. So some consider this a disadvantage, that is why I mentioned it here. But I will also mention that when I say source-based, it does not necessarily mean source code. Because as I also said, the source, the software you install can be whatever. The Portage just handle how to actually install it in your system. It doesn't care really what it is. So it could also be binaries from CD. Portage is slow. This is another big. Usually people complain about Portage is slow for searching the package tree. And if you
install your machine? Once every year, I don't know.
Again, I mention it because it's a reoccurring flame war.
Well, if you're making many machines, then they're real big.
And several people has claimed that Portage sucks because it's written in Python, so now they wanted to make the new Portage in C, and then you never heard from them again.
If you start many machines, just install one and just guard your entire...
I don't consider this disadvantages, but I should mention it.
You can also do binary packages anyway.
Yeah, you can.
Yeah.
I will come back to that. Portage does not support per user installation. This means that while Portage handle system-wide installations very well, for the subject of this talk, making your own e-builds, you might think, hey, you can use Portage for having your users install just simple things in their own home directory. No, sorry. No can do. It's on the to-do list maybe in 20 years.
Why 20 years? I'm gonna get this done.
Yeah, go on.
Yeah,
It's
I'm
not,
gonna get this done soon. That shouldn't be that difficult.
it's not that hard, really. It's just they want to do it in a really clean way, and
Yeah,
This year.
I can hack it up in 2 days.
yeah. But it doesn't support it right now.
Well, does RPM doesn't either, right? Or do you
No.
package? Do any of the big
No, no,
package
no.
managers support that?
No.
Okay, cool. Just wanted to.
Yeah,
Yes, but being source based, that's the point. That's very good to
Yeah, I mean,
to get it.
Like I
on
said,
the phone.
it's not hard.
Yeah.
no.
E-builds are, but you have to convert all the e-builds to support it. That's the hard part.
That's
Is it-
probably the thing is,
Basically-
if it hasn't been existed, it probably means that there's not enough demand for people who really care about per user installation. So it's probably the minority who really has to take
Yeah.
People don't have it in their systems.
Yeah.
So, but anyway, I just want to
Sorry,
clarify
sorry,
that
sorry.
these four things, I do not consider them disadvantages, but they reoccur as people mentioning this as disadvantages. That is why I'm taking them here. Portage does not support SysMark. This is interesting if you run Portage, try to run Portage on a big server farm. Portage does have some locks, they have implemented some locking themselves, and if you want to, for instance, send them this to another machine, you have to handle this external. But now, first of all, I'm going to show you how to use Portage seen from the user side, mostly to cover the terminology. First one, packages in Portage are called e-builds. And you will find that everything that revolves around Portage has an e-name, e-something. I don't know who came up with this, but that's how it is. And yeah. E-builds are, as I said, meta packages, which means that the package itself just contains information about dependencies and how to install the software, maybe uninstall the software. It does not contain the software itself, meaning that the e-build is per default DPL. I don't think you can change that in any way, but the software can have whatever license.
Yeah, and the e-build is UPL, and the copyright belongs to the Gentoo Foundation. So if you contribute an e-build, it ain't yours anymore. I mean,
Yeah.
it's just the way it is for legal reasons.
But it just covers the e-build, not the software itself. E-builds, talk about naming. E-builds have two levels of versioning. For an e-build, you have the version of the software that the e-build installs, and then you can have a revision of the e-build, meaning that the same version of some software can have several different revisions, different e-builds with different revision numbers. This is useful mainly because people make e-builds and they screw up somewhere and they make a new e-build for this very same piece of software. But it's useful when you start reading names of e-builds that you actually know what has to do with the software and what has to do with the e-build itself. And another interesting thing is that e-builds can be considered stable, unstable, or masked, but again, that refers to the e-build, not the software. So, an unstable e-build does not mean that the software is unstable. It means that the e-build itself is considered unstable. On the other hand, a stable e-build might install an unstable version of some software.
Typically not, but
Typically not, but you could have something that has been called a beta version for 5 years and you say, oh, what the hell. Okay. E-builds are then put into categories, so it's like a kind of a two-level tree. You have category, e-build name, version. And usually with many of the tools you can just use the e-build name, but to solve ambiguity you can also specify the category to specify exactly which e-build you're talking about. Okay. When you install something with an e-build, it falls into one of four groups. Either it's system, which means that it is something that is mandatory, defined by the system's profile. If you, for Gentoo users, you rarely consider this because in your installation you select a profile, and sometimes Portage might say, oh, you want to upgrade your profile, do these two things, and you don't really think about what it is. But basically, Portage has a profile for the specific platform, which says that for this platform there are these 5, 10, 15, 100 packages that we need to have a running system.
Just to highlight something on the system profiles, this means when a new version of Gentoo comes out, you don't need to touch installation media. You can upgrade your system completely safely, like, you know, with Red Hat and Mandrake, if you attempt to upgrade, you usually hose yourself. Not so in Gentoo, so new releases are mainly a PR deal in the Gentoo world. That's what the system does. Exactly, right. Faster though. I mean, release cycles are faster.
That's right. That's right.
Now,
Keep out gallery.
the second category, most interesting, is world. That is what you, as the owner of the system, installs. Whatever you ask Portage to install specifically goes into world. And then the third, dependencies. Things that has been installed by Portage as a dependency to something else. And the difference between world and dependencies, the main difference is that dependencies are only dependencies as long as they are needed by something in system or world. If they are no longer needed, then they become redundant, and Portage can actually identify that. So, if you install some new piece of software that you want to try out and installs like 20 libraries, and you find out, oh, you don't use it anyway, you don't have to keep track of which 20 libraries you install as dependencies. When uninstalling something from world, everything that was a dependency before becomes redundant, and Portage knows that. It doesn't automatically uninstall it, but you can ask it to. The two most important gotchas with this system is one, if an e-build is removed from system and it isn't a dependency of anything else, then it also is considered redundant. This has caught a few people. For instance, when Gentoo decided that not everyone needs a DHCP client. So they removed DHCP client from system. No one had installed it because it was there, because it was part of the system. And when they cleaned up the system, it was gone. And all of a sudden they didn't have a network. So, when you update your profile, please consider looking into what the changes are. You don't really have to look at all the profile files. It's enough, usually it's enough just to keep an eye on the newsletter. But it teaches one important lesson: know your system. Know what is there because it's a dependency, and know what is there because you want it to be there. Another one, an e-build is in world or in a dependency depending on how it was installed. Meaning that if you install something and install something else as a dependency, even though that you have later found out, hey, you want this something else to stay in your system, it still counts as a dependency until you tell Portage it's no longer just a dependency, it's now on work, because you want it to stay no matter what. Again, know your system. Make decisions. Okay, keywords. Portage has been ported to many different platforms, and each platform is given basically a keyword. And each e-build can have one or several keywords with a prefix which defines how is this e-build doing on this particular platform. So, if you just have a plain keyword, it means it's stable. And most of the packages, of course, have the x86 keyword, probably with a prefix, but it means that you can, if you make an e-build, any platform it can run on, you can just add the keywords and anyone else can use it. So you tell people how this particular e-build is running on this particular platform. If it has a tilde in front of it, it means it's unstable. And the definition of unstable kind of depends on who's maintaining the package, but I think the most widely used is that the maintainers think that it is ready, it is supposed to be stable, but it has not been tested yet. So they put it out, and anyone who doesn't have a system they really depend on can try it. And yeah.
Any Debian users should realize that an unstable package could be rock solid. Gentoo's dev policy actually says when you write a new e-build for a new version of software or a new piece of software that wasn't there before, it goes in unstable to the Portage tree, and it doesn't get marked stable any sooner than a month after it's been in wide circulation. So if it's marked stable, if it's marked unstable, you don't really know what that means. But if it's stable, you can be pretty damn sure that it's not going to break your system, because hundreds or thousands of Gentoo users out there have installed it and not reported bugs. And the policy says that during this trial period, if bugs are reported, then that bumps out another month. So you have to have a stretch of 1 month where no e-build related bugs for that package are supported, and then it can become stable. So.
Can I ask a silly question on that? What if you release the e-build, it's there, and no one bothers to download it, so you have a month of just non-use?
Well,
is that checked? Is there a check to make sure that the people are installing it? Or?
The maintainer of the e-build will know about how popular it is. Okay. So, I mean, yeah, it is a bit of a judgment call, but the point is that if it's marked stable, at least you know that no bugs have been reported on it in a while. So that's what we do.
But again, this is how it's handled in the system, and then depending on which package tree you're working with, there can be some policy. On the official Gentoo Linux package tree, this is the policy, but you might want to have an overlay for e-builds you just use internally in your own company for your servers, your own e-builds. And then stable, unstable can mean whatever it is you enforce it to mean. It's just how the system handles it. So basically you set up Portage to allow it which keywords you want it to install. Usually you say you just have your platform, and you say you want to go with stable. And if you run an important server, you want to stay just with stable. If you want to try out a few things, then you have just accept stable keywords, but then you override it. This is where the per package configuration comes in. You can override per package saying, oh, but this package I want to try the unstable one. And if you're really dumb, then you just go with completely unstable, and then your system is broken within a month. But hey, choice. Another possibility is when something is prefixed with a minus, it means it's masked. And it can be masked for different reasons, and again, I won't really come into policy. This is more about Portage than it is about Gentoo, so. But it usually is used when you want to put out an e-build, but it's not intended for use by anyone else besides people who really, really want to test this bleeding edge thing.
99% of the time in practice it's used for security advisories. So the Gentoo Foundation does that to cover their ass when there's a security vuln and OpenSSH that hasn't been patched yet. They mask that version of the package. You can install it at your own risk, but you have to work a little hard to do it. So that's what it is in practice most of the time.
Yeah. Or as I've also seen it used a few times as placeholders for future software. One example is the upcoming new version of XOR. It hasn't been released yet, but Gentoo Linux has all the packages for it ready as placeholders, basically. Yeah. Do interrupt me if there's anything. Use flags. Well, the people who built Portage thought that, well, a lot of software comes with the usual make files, .configure files, whatever, and everyone who's used .configure and make knows that you usually do .configure and then enables or disables support for different libraries and whatever. But it might not always be that way. Maybe you install something binary, maybe people have not used .configure, just make, maybe they use something completely different, or maybe it's about whether or not you want to include something. Anyway, they thought about this system where use flags are basically binary switches, on-off switches for something. And this something is a little undefined. Usually it means that if you want to install something with support for a library or some other function, or you want to have all the documentation with it or not. You use it to configure what is installed when you install an e-build.
This is the beauty of source based. You see, that's why I said, like, why the disadvantages shouldn't be considered disadvantage. Yeah. See, like, for example, you get a binary that has KDE stuff in it, but you know, I use TWM, you know. So why do I need all this stuff into my binary? So that's where it's so beautiful here.
Yeah, that's where RPM hell came from.
Right.
When you try to install, Vim on Red Hat and you get like 50,000 dependencies.
Right.
Yeah.
Everything relies on Xpeng, so.
Right. Yeah, right.
Yeah. But the idea here is that they have this abstraction layer, use flags, which you can use in some way. So with the use flag, you do not really, as a user, you indicate what you want, but you don't really specify how you want it. And this is used for some of the most used ones are, for instance, if you have, there's a global use flag called KDE. If you set that, you indicate to packages who support this use flag that you want them, if they can support KDE in any way, they should install it in some way. It can mean, for different e-builds, it can mean different things. It can mean anything from installing scripts to linking to libraries to employing some special hack that actually makes it work with KDE. It doesn't really matter. You specify that if there is some KDE support, you want it.
I think the use flag is actually the most important part of the Gentoo.
Yeah.
Which is definitely part which is make it. Actually, for example, if you want to install Apache without PHP support, so you can put -PHP. So
yeah, most
of the distribution will install PHP already compiled with PHP support and so on. So it's deep code, which is anyway will not use it. So
exactly.
why should you?
Exactly. But again, this is the usual use of use flags, but it doesn't have to be that way. You can use flags in your e-build to switch on and off anything you basically like. It's just a switch. is what actually happens when you set this switch on and off depends on the e-build.
It's beautiful.
But most often it does something to the dependencies. No, okay, just quick run over how easy it is to use just as a user. The usual command you want to use is emerge. Portage itself is more like a Python library, but then you can have stock different programs, tools to use this library, and the most used is the official emerge command. For installing a piece of software, you go emerge, ebuild. I usually use these two switches, A and B. B for robustity. It shows exactly which use flags are set and not. And A for ask, show me what you're going to do, and ask me if it's okay. There's a lot of different switches you can use. I'm not going to present them all, but it's my experience that I almost always want to use AB whatever I do. It's a good thing to do.
Yeah. So that's really the same as excuse me, running emerge-vp and then rerunning emerge without the
Yeah, exactly.
It's a new one to me actually.
No, it's very useful. And it's a good rule. Review what the system is actually going to do before you commit it. Allow the system to continue. Again, know your system, know what's going on. Now, once you install something, you want to keep it up to date. Maybe. But if you want to do it, there's different ways to do it. Well, if you just say you want to upgrade, if you just say upgrade world, the U means upgrade, the big D, the capital D, means with dependencies. So now you say, I want to update everything I've installed, plus everything that is a dependency. And this is a very useful way to just upgrade the whole system to everything. You can also, if for instance you're a little more concerned about just upgrading every piece of software you have on your system, for instance, just say, I just want to upgrade, in this case, we just want to upgrade the system, just the profile stuff, not the world stuff. And in this case, we have also removed the capital D, means just the specific packages specified by the profile, not the dependencies. It might take some dependencies anyway, because dependencies are calculated dynamically whenever you do something, which means that if you upgrade to another version of an e-build who has a dependency of a newer version of one of its dependencies, you can, in your dependencies in your e-build, specify not just a piece of software, but also a certain version of the software. So you might have a dependency in it anyway, but it doesn't do that automatically. It doesn't go all the way down the stream. Oh, nice. If you're wondering about the O, it's because this is translated. This original this was originally done in Danish. Yeah. Anyway, you can also just upgrade a single piece of software. So you can upgrade whatever you want.
Never expect that if you upgrade the wall, for example, everything's going to go smooth until the very end.
No, but again, you can
to troubleshoot it on the way.
Yeah.
A lot of times.
But this is one of the good things. You can employ your own policy of how you use Portage. In a production environment, you usually want to only upgrade when A, there's been some kind of security hole fixed, or B, maybe once every other month just to keep the system up. But then you have also scheduled work to make it running afterwards. Schedule some time to make it work afterwards. But you can also be a home user, want to do bleeding edge, and you do this every day. That's me, by the way.
People, yeah. Lots of people who have that in their cron tab and
yeah. But you can do it what it would.
Yeah, but
Yeah.
like I said, this is
My DHC
never goes
plan is
to
Well,
gone.
not system.
Okay.
System like
Yeah.
I think this is sheer insanity, by the way, as a Gentoo developer, but whatever.
Yeah.
Users can do what they want.
Yeah. You can also uninstall and rebuild, and here it only uninstalls what you actually specify. But then once in a while you might want to clean up your system, and this is the power and the danger of Portage. Because you can here ask it to do a dep clean, dependency clean. Basically what it does, it says, okay, we have system and worlds, we have all the dependent packages, and then we have all the rest. And all the rest, gone. This is why you want to always, if you don't use it with any other command, always use A or P here. P for pretend, A for ask.
Any reason why you don't have dash V either? Any reason why you don't have dash V in the dep clean?
You don't need it.
Yeah, it doesn't make any sense there.
Yeah, use flags don't mean anything to uninstall. They just mean something to install.
Yeah. So,
even for Parm, right?
you wanna,
Even minus B.
with A, it will
Yeah,
give,
I didn't understand.
with A for ask, it will give you a list of what it actually is about to uninstall, and you want to go through this list e-build by e-build. But it's a nice way to keep your system clean and sitting, because you, after doing this, you will only have what you actually need. There is a few gotchas with this command, which is why it is considered a little dangerous. What it uninstalls depends on the current dependency tree. The current dependency tree depends on your use flags, your current use flags, which might not be the same use flags as you actually used early on when you install something. Meaning, if you install something depending on a library, then decided I don't want that, so I switched off the use flag. But you didn't recompile that package. The package the software is still linked to this library until you actually recompile it, reinstall it, so it can use the new use flags. So if you just uninstall that library, you will have a broken piece of software. It might not be a problem, it might be some software you can just discover it's broken and then just recompile. It might also be something that your system really depends on, then you have a problem.
Excuse me, may I have some confirmation?
Yeah.
What is redundant exactly in this process? Is it several versions of bash or something?
It is basically anything that is not either A, in your system, B, in your world, because you have put it in the world, or C, a dependency. Anything that is not in one of those three groups is redundant. It shouldn't be on your system.
Or another possibility, for example, for the last few days for kernel, it's almost two versions now, like 2.6.1.4 or 1.2.6.1.4 or 2, just today arrived. So when I upgrade the system, I want to recompile the kernel with the new security updates. So when I emerge -C, uninstall the kernel after recompilation, for example, its other version remains. I don't delete from my system. So to make it more clean delete, I use usually this emerge -deep clean. So to clean completely the system or any other packages which I don't need it.
Oh, I see. That must be dangerous.
It is a little dangerous, which is why that you want to make sure that you have actually, you can also give a switch to emerge that tells it to upgrade packages or recompile things that has new or changed use flags. And you want to do that before you do a dep clean. And you still want to look through this list. But it means that unlike, for instance, with RPM, you can make sure that if the library is there, it's because it's needed. It's because something that you have specifically installed needs it. Or you have specifically said that it should be there.
Another way you can get around all of these problems is if you create binary packages of everything you compile, because then if you mess up, you can reinstall it.
Yeah, that's another.
Of course, if you break Portage or you break a merge,
Yeah.
Exactly.
yeah.
But the whole Gentoo philosophy is really to expose as much of the system to the user. So in other words, to give you plenty of rope with which to either mess with the cows or hang yourself. So you can do anything, and just like with a chainsaw, that can be a good thing or a bad thing, depending what you're using it for. So.
Okay. Now, time to get a little bit more dirty. Let's look under the hood. If we just look at the file structure, I'm not going to go all over it, but just where to find files in a usual Gentoo Linux system. And this means that this part is specifically for if you use it on Gentoo Linux. If you use it on a Mac, it's somewhere else, and I have never owned a Mac, so I would have no idea where to look. But usually you will find, in user Portage, you will find the official package tree, including profiles and other stuff. But basically this is the official Gentoo metadata, and you can synchronize this whenever you want with online servers using rsync. So basically you download all the meta information on your own machine whenever you synchronize the tree. Of course this is only possible because it is only metadata and not all the source code also.
And that's just a switch to the emerge command. It's emerge -- sync. And that is something that you can have in your cron tab completely safely. I run that every night to make sure I have a fresh Portage tree. Now I don't want to install the packages from that fresh Portage tree automatically, but so that's completely safe. Do that often.
It simply means that you update what Portage knows about existing evils, nothing more. You will find that everything lies in a nice, just in the file structure. So categories are just directories, and then you have subdirectories in these category directories, which are for each piece of software, and in these directories the e-builds themselves are. So it also means that if you're curious about what an e-build does, you just go down to the right directory and open up the file in your favorite editor and read what it does. More interesting, you also have in this structure, the user Portage profiles, you have all the profile information. For most people, they don't want to mess around too much down there because profiles are made by people who know what they're doing, which does not include not even normal developers. But you can find useful information there. So look but don't touch.
Yeah, and Portage will notice when there's a new profile that you should be using, and it'll tell you about it. It'll tell you how to switch to it safely.
Yeah.
But Martin's absolutely right. I mean, the developers who build profiles are like 3 guys. And of all the hundreds of Gentoo developers,
So another interesting directory is the e-class subdirectory, which contains all the e-classes. Again, I will come back to what that is, but basically it's files with reusable code, and you can find it there. Again, if you want to know what something does, go ahead and read. The system-wide configuration file, basically there are two, but one of them is actually only a symlink. Make.conf contains the system-wide configuration for Portage. This is where you specify your compiler flags. This is where you specify which system-wide use flags you want to set or unset. You specify how Portage should behave. You can even specify to put the whole port tree somewhere else. It's where you find all configuration stuff. You also have an etc profile make the profile, which is just a symlink, into one of the profiles here. So upgrading from one profile to another means changing the symlink, and then asking Portage to handle whatever changes that has been. That is that easy to upgrade from one version of Gentoo to another. Then you also have etc Portage, where you can have several different files containing per package configuration. So you have a system-wide configuration which covers everything except what you override in the package configuration files. I think there is some new files that does stuff that I haven't looked into, but the most important thing is you can mask or unmask ebuilds. Means that even ebuild is for some reason masked, you can unmask it, say, hey, I want to use it anyway. But you can also go the other way and say, oh shit, here's an ebuild that everyone else considers stable, but it breaks my system, so I want to mask it. I will never, ever, ever see it in my system. Very useful if you have a production environment. You can also specify that you want to allow certain unstable ebuilds, and you can override use flags. In both ways, setting and unsetting.
Can I interrupt for a second?
Yeah.
Since we're at slide 10 of 27,
Yeah.
time-wise, if we can maybe just try to keep questions to only pressing questions and just speed up a little bit.
Okay, sure. Some of the slides are quicker. So anyway, now it comes to, we have to know a little about what's going on during the installation phase or uninstallation phase of Portage before we can actually go on and make our own ebuilds. Basically, when Portage installs something, it does it in these different stages. The first thing that is executed is the fetch stage, which basically means that Portage will go in, read the ebuild, and in the ebuild you specify where the hell you're going to find whatever you need for building or just installing the software, and it will fetch it. The ebuild might also specify that Portage cannot fetch this automatically. The user has to do something manually outside. This is, for instance, the case with Sun's version of Java. Yeah.
Real player.
Real player is another. Yeah. Whenever it has fetched something, it is put in a temporary directory, and it is checked with, at the moment, MP5 checksums. It also means that if something is already there, it will not re-download it. Then it will unpack the source. And again, remember the source just means whatever you need. And it's unpacked into a temporary directory, which for the rest of this is called the sandbox. Basically what Portage does, it prepares the software in a sandbox, which is actually created in such a way that to protect, it's not really security, but to protect the developer, it will only allow you to make changes in the sandbox. If you try to change any files outside of the file system, you will get an error. The ebuild itself can override this if it wants to, because the ebuild might need to change something outside. But the main idea, the main philosophy is that you want to prepare everything on beforehand in the sandbox, and then let Portage merge it into your live file system. And we'll see why this is important. Then you have the compile phase. These stages are, I use say phase or stage, it means the same. And the compile stage, these stages are named because it is mostly for compiling software yourself. You can put whatever you want in these stages, basically. Then you, after compiling it, you install it into an image directory. Basically, you build the whole it builds a whole file structure as it should appear in the live file system in this directory. And this is done because whenever the install phase is done, then Portage can actually read this image and see exactly what it's going to install in the live file system, so it can also uninstall it. And it records MD5 checksums for everything.
Also, at this stage, you can automatically have binary packages created.
Exactly. Yeah. And then the merge state, where it basically takes the image and merges it into the live file system. Now there are also some optional stages. The no fetch stage is executed whenever Portage cannot fetch something, not because you don't have internet and then you get an error, but if you in the ebuild specify that for some reason Portage cannot fetch this itself. Usually it's used to just produce a message to the user on how to proceed, how to, for instance, go to Sun's website and download Java yourself and put it in the right directory and then try again. The test stage is fairly new, but basically if you want to test everything before you merge it into your live file system, then packages that has a test stage will execute this stage. And you can also have a config stage, which is doing something after the merge. Usually something about initializing databases or whatever, which has to happen on the live system. And therefore it also requires the user to manually do this. Manually tell Portage to now execute this ebuild's config stage. Okay. Let's go back to the ebuilds. The ebuilds are basically bash-like scripts. And I say bash-like, even though it actually is a bash script, it is executed within a controlled environment, so that's why I call it bash-like. So, if you can read bash script, you can read the ebuilds, even the existing ones. The meta information, description, what use flags it knows, where to find the source code, dependencies, whatever, are just variables, bash variables. And the individual stages are implemented as functions. So, if you want to write your own ebuild, you just make this nice bash-like script, make some variables, make some functions, stick it into Portage, and that's about it, basically. Source unpack, source compile, source install, source test, source config, we already covered that. These special package, pre-install, post-install, pre-remove, post-remove, are kind of special. Some packages might need to do something on the live file system during the merge, which is of course is usually not allowed to because it's in the sandbox. This is where you can do magic stuff if you need it. One example could, for instance, be if you want to have a package for your special binary compiled kernel, and you want to automatically put it into your grub configuration whenever you install it, and remove it from the configuration again when you uninstall it. This is where you can do it. Not so many packages actually implement this because they try to stay within the sandbox, but you can do stuff here. Whenever these bash functions are executed by Portage, Portage also has set a lot of other variables with information that you can use in your rebuild. Most usefully, it will tell you, or actually it will tell the function where the image directory it should write the image to is, and where the sandbox is, and the package name, the package version, that. We'll see how that is used. Portage also provides a lot of useful tools that makes creating e-builds easier, but these are all optional. And this is not exactly, last time I checked the documentation, it wasn't exactly clear. But it has a big toolbox, and if you like it, hey, use it. If you don't, you write bash scripts as you would normally. It has some nice things. The most useful I've come about is, for instance, it has a changed version of seed, which instead of having to write to a temporary file then copy back, it can seed in place. Useful. It also has a special tool for creating directories, and you can use them, or you can use make here, whatever you want. And you can also, within the e-build, execute anything else you have on your system, of course, as long as it does not change anything outside the sandbox. But it means that you can use other tools, you can use whatever, tar, RPM to tar, gset, whatever you want, as long as it's installed on your system. Now, for creating your own e-build, the first thing you want to do is you want to create an overlay. And why don't you just want to change user Portage? Well, one thing, every time you synchronize with rsync, you override it. That's a bitch. You have to recreate your e-builds every time you synchronize the official package tree. Another thing is, usually the official package tree is look but don't touch. So you create an overlay which is a partial tree which is overlaid on top of the official tree, and you can have several overlays. And depending on how you order your overlays, Portage will see the sum of that. It means that if you put in a new version or a whole new piece of software, you will see it in the complete package tree. You will see it along with the official packages. It also means that if you put in an e-build with the exact same version of software, you override it. Useful if you want to, for instance, apply your own patch. Decide on where to put your new e-build. If you are just making a new e-build for something that is already in the official Portage tree, then go with that. But if you install something completely new, spend more than 5 seconds thinking about where to put it, just to keep it organized. Create whatever directories you need for the category and the e-build itself, and populate it with some skeleton files. In user Portage, there are some files called skell.something, and you copy them over and rename it to whatever is after skell, and that's your starting point. You have a changelog file and your metadata file. Mostly useful if you're later on gonna submit your e-build to the official tree, but in general it's a good idea to, for instance, keep a changelog for whatever you do, even if it's just your own packages. And then copy the source directly to user Portage dist file. This is for avoiding, whenever you're testing your e-build, you probably have to run it at least a few times just to test that you actually rebuild doing what it wants. So you don't want it to go out on the internet and fetch the source every time. So just put it in there and Portage will discover it. Also, you need to manually put it there for the first time you run the e-build, simply because before you can execute the e-build, you have to make a digest. Record MD5 checksums of the e-build and the source files, which means that it needs the source files to be on your machine in the first place.
Well, digest will pull it though from the internet.
Okay.
Based on the source, so you
Okay.
don't necessarily have to put it there the first time. It's just faster.
Okay.
If you have it, why not put it there?
Yeah. Okay. That's changed then. Okay. Then the more interesting thing, edit the e-build. We'll see how that looks. And then make sure that Portage has a copy of the license for this software. Every e-build records which license the software is covered by. And if Portage does not already have this license, make a text file. Take a copy of the license, put it in a text file, stick it in a license directory in your overlay, and you're up and running. This is important because actually Portage enforces this. If it cannot find a proper license file for an e-build, it will not install it, because the user should be allowed to see the license before you install something. But it is as simple as just making a text file and stick it into a license directory in your overlay. Update your e-builds digest. This is done automatically. I'll show you, and then test it. And that's about it. That's the checklist. So, let's try something simple. This was done before the official suite decided to finally update to a modern version of MesaLib. I created an e-build for a newer version of MesaLib. Mesa, actually, I just call it MesaLib. So what we do is, I go into my overlay, I put it in user local Portage, which is the default place. I have decided that I want to stick MesaLib in MediaLibs, the MediaLibs category, so I create those two directories. I populate it with the changelog, metadata, and the skeleton for the e-build, which I rename to MesaLib, and then the version of MesaLib. Now, if I would make more revisions of this, I would put a -r something on it, but as this is the only revision at the time, it is revision 0, and you normally don't show that. Question? Okay. And then I just get the source and put it into user support test file because it's faster. So, what to put in metadata? Metadata basically contains, most useful, an email address to whoever is stupid enough to decide to maintain this package. The one person you contact if something doesn't work. In this case, that person is me. So I put in my email address here, and if I want to describe exactly what I mean by maintainership, which could be anything from, hey, if you have a problem, contact me, I'm going to solve it within 24 hours, or send me an email and I might get a new version out in 6 months. You can put a description. It's just a text file used for people using your e-build to see what you actually mean by you maintain it.
Yeah, but submit your bugs to bugs.gentoo.org. Don't email developers directly, we get angry. Or we just don't reply.
And if you feel like it, you can also write a long novel about this package and whatever it does. I have yet to see someone actually filling that part out, but... Okay, the changelog. Well, we haven't really changed anything, so I just put in that it is the initial import. And the skeleton file has a description of what format the official Gentoo package tree want the changelog to have. And if you want to submit your package, follow that. If you don't want to submit your package, hey, do whatever you want. It's just a text file. But one thing though, by keeping this format like this, where you, for every e-build, specify what has happened, you can actually ask Portage to show the changelog from whatever version you have installed to whatever version is available. If you do something else, Portage will probably not like it. Now, the e-build itself. In this case, I have given a short description. I have pointed to the homepage of where the software comes from. I show here where Portage can find the source, and you'll notice that this variable, this is one of the variables that Portage provide, which means in this case this one is package version. Means that this line I can keep copying for every version. This is just me being lazy. I could also just write the version, and then when I make a new e-build of a new version, I may sort of change it. But if you maintain a package, it's useful that most of your existing e-build can be reused whenever you make a new e-build for a new version. The license is the MIT license. The slots, I will not go into slots today because that is a bit more advanced. I have here been specified the keyword that I consider my e-build stable in my first attempt. That might be a little stupid, but since I'm only running it on my own machine, then I can do whatever I want. A better policy usually is to create it unstable, and then, even though it only runs in your machine, override your package configuration and specify that it's this specific package you want in an unstable version. But again, you can do what you want. I use which use flags this package knows and does something with. In this case, none. It doesn't care about use flags. It does not depend on anything. Again, if the author of the e-build makes mistakes in for instance, dependencies, of course, then the e-build will probably break. That is not Portage's fault, it's the author's fault. So, but I didn't really find any serious dependencies. Of course, you can specify there therefore are of course some dependencies, so maybe some standard library stuff.
Like virtual glibc.
Virtual glibc, but the usual policy is only put stuff here that you know is not in the system. Thing that is obviously on a system, you don't want to put here, because it's redundant. Restrict. I have specified no mirror here. It basically means that Portage should always go to this address and not try to find mirror. I will not go into mirrors. You can learn this yourself by reading the existing official e-builds. R-depend. You can actually specify two kinds of dependencies. Depend is just things that the software you install depends on for running on your system. R-depend means things that Portage need for building the stuff.
You had it backwards.
Ah.
R-depend is
Oh,
for
sorry, yeah.
runtime.
Runtime dependency, yes, okay, sorry. R dependencies are for running, depend is for building, sorry. And in this case, this is an old build, I actually specified S, unless when you unpack your software, it makes some strange structure, you normally don't want to override S. S specify where the source is put, basically.
The sandbox.
The sandbox, yeah.
Yeah, and he has continued here, but it's interesting to note that if this software package uses the standard /configure make install nets, that's a complete e-build. You don't need anything more. It'll just install from that. So
Portage has some default implementations of each of the states, and if you can use them, hey, go ahead. If you need to do something else, then you can overwrite them. You can also overwrite them just because you want to make sure that even though Portage might change something, your e-build doesn't. Again, your choice. You'll see that this e-build is pretty small. I have here chosen to overwrite compile. This is because I, for Mesalib, need to not just run make, but also actually run it with a specific target. But this is a compile state. You will notice there are no unpack stage, because Portage knows how to unpack a tar GZ file. And the install, say I have chosen here to use the doDear tool. This is simply a makeDear wrapper which knows that it's in the sandbox. So by telling it I want to have an opt meta directory, it knows that it should actually create opt meta in wherever the image is, the image directory is. But you can also use mcodear if you want. And then I simply move stuff from lib to mesa and from include to mesa. And that's the structure I want in my image, and Portage will handle the rest. It's as simple as that. So all these .configure make packages you want to install, it's really, really easy to put them into an e-build, and then for free getting dependency handling and uninstall ability. Now, after that, we use the e-build tool. Basically, actually, Portage is kind of a tool-level thing. Portage is more like the high-level dependency calculator thing, and whenever it actually executes something for a state from an e-build, it runs the e-build tool with an e-build. But you don't have to worry about that. Just know that you can run individual stages with the e-build tool. So in this case, I simply just specify the full path to my e-build and ask it to make it digest. And then I try to, just for testing purposes, running each of the stages, unpack, compile, install. And when I see that that actually works, I don't have to really test merge because that works. But then I want to see it actually works with dependencies and all. I try to run it from the emerge command, and it works nicely, and then I install it again. And that's it. That's my package.
Except for the digest step, the other e-build commands are, he's just doing them optionally. You could just jump straight to the emerge and it would suck and do the stages.
But on that note, I have found that usually whenever you think that you're lucky enough to have gotten it right the first time, you end up spending much too much time debugging it. So test them individually anyway. It doesn't take that much longer. Okay, let's see another example. More interesting about this is a piece of software called Robius. It's a binary piece of software for controlling some small robots that we have in a lab in the computer science department at Copenhagen University, and it comes as an RPM package. How to deal with that? Well, this page has nothing really new. I specify, now it comes as an RPM package for the tool chain. This is actually a cross compiler, and then some library that comes as a zip file. Most of this you will already know, license, slot, whatever. In this case, I depend on, I need RPM to target zip for handling the RPM package, and unzip for unzipping this file. But they are own dependencies. I also specify R dependencies to have nothing. Once I installed it, I don't really need these tools anymore. If I hadn't specified R depend, they would just be the same as depend. And in this case, I again override S, but this is more specifically because I know that these two packages put the software in a other kind of structure than the usual.
You have the default there, don't you?
No, usually that's the version also.
No, P is the package plus version. P
Oh,
is
sorry,
just the name.
Yeah, sorry, yeah. Then it's the default one. Then it's redundant. Okay, unpack. In this case, I want to override the unpack stage because I need to unpack the RPM and I need to do something else. I go to the work directory. I basically unzip the zip file and create a tar file from the RPM package. Notice that I don't unpack the tar file here. I will come back to why I don't do that later. But then, it's a binary distribution, so I don't really have anything to do in the compile. So I just stuck a nice little note for the user to look at, and don't really do anything else. And then, in the install phase, I choose to unpack the tar file that I created before. Now, this shows two things. First of all, I did this because this has to run on a fairly stupid file system, with a fairly stupid file system, so unpacking to one place and then in a second later moving it to another location is quite redundant, so I just unpack it directly into the image directory. The second thing it shows is that even though that we have these stages called unpack, compile, install, you can really do whatever you want in them, just that it makes sense. I don't have to unpack everything in the unpack stage. I can do it here.
It looks like a shell function. Its syntax is
Bash.
shell, bash.
Bash.
I see.
And whatever you can do in Bash, you can do here.
Oh. It's good.
So, for people who don't know much about scripting, usually say, well, you think about an eagle as an how-to list for how to install a piece of software that you can actually execute. Because that's what it is. I create some directories, move some things around, set some nodes, and that's about it. Then I have here two environment variables that I put into a special structure, but I won't come into that because that is strictly Gentoo Linux specific. You can read about that somewhere else. But basically, a script, like anything.
That's quite good. People started realizing how much they miss by using other distributions.
Now, E-classes, I won't really explain E-classes because it's quite a big topic, but the main idea in E-classes is that when you create many e-builds, specifically you create one or more revisions for every new version of software, usually you end up doing some things over and over and over again, so you want to reuse code. This is where E-classes come in. E-classes are basically stuff you can import into your own e-build and use. But it's a little more advanced than that. An e-build can just contain additional functions or even additional variables if you like it, but it also implements something that mostly resembles C virtual functions. Basically it means that it can override the default behavior of stages, and unless you re-override them in your e-build, they will be executed instead of the Portage default ones. So, and this is an example, this is actually an official package. Now I want to show exactly how powerful that can be. Whatever happens here is not really important. This is a source file, and basically the Gentoo sources software is basically the official kernel source with some patch set.
Lots of patches.
Lots of patches. So installing this piece of software involves getting the official kernel source, getting all the patches, finding out what patches you need, do a hell of a patch job, and doing it in the right order, and then you have your source and install it. And it can be, if you did this manually in every package, I think it could be tedious. But instead they have made an e-build, they inherit kernel 2. And then they have You should recognize that. But you also have some variables up here. These are not official Portage variables. These are variables used by the class, and you have to read the class to understand what they do. So it's just to show that you can use your own variables too, if you want. And then specify home page, and the source where you see that it actually doesn't have the source directly. It specifies some other variables you haven't seen either. So they come from the class too. And then, well, the implementation itself. Well, you have a setup phase where it does something magic with the Ultra One. If there is some special patch for some special kind of combination of platform and setup. And then there's a post-install thing that gives a message about what happens up here. But where's all the unpack? Where's all the patching? Where's all the image thing? It's all installed in the E-class. Meaning that when they make a new version, they basically take a copy of this, change top 10 characters, and they got a new version. Because everything else is already handled in debug. Oh, sorry, D-class.
Yeah, even more impressive if you look at most of the stuff in app KDE, the e-builds are 5 lines. They say inherit KDE utils, and they set source and that kind of crap. Those e-builds, I guarantee, are never changed when the software is upgraded. They're just simply copied to the new, file name for the e-build, and magic.
Yeah. So, if you want to really create powerful e-builds, you can start looking into this, but create some simple e-builds first. Because how exactly these e-classes work within Portage is a little more tricky than this simple explanation here. Now, last few slides. First gotcha, remote to recreate the digest after every change. Portage will complain if the digest does not match what you actually have. And every time you change the e-build, you change the MD5 checksum of that specific e-build. So you have to, recreate the checksum. The point of this is that whenever you download something, Portage will check that it matches. So if you have, this also goes with the source, that if someone tampers with the source, as long as you have a same e-build, it will discover it. So it's safe that Portage just automatically downloads sources from unknown places and install it. Now, again, this one we already covered, test the stages one by one. This is a personal experience. I have many times thought that this time, this is so simple, I got it the first time. I didn't. It's a waste of time just trying to run it and see it horribly fail, because it doesn't take any longer, it just takes a little more time. If Portage misbehaves, try to delete the sandbox and the digest files. Well, this has something to do with the way you normally debug stuff. You run something until it breaks, and then you change something, and then you try to run it again. At the same time, Portage will try to reuse as much as it can. And of course, it can mean that at some point, the sandbox and the digest file might be in some kind of invalid state, but Portage can't really determine that. So anyway, it's basically delete the cache, start from scratch. And whatever is in the sandbox is recreated whenever you run the e-build again. So it's safe to delete. And digest, you can recreate it. Learn by looking at similar e-builds in the official package tree. This is the main source for learning stuff. There's a lot of documentation out there, but there's not anything that is as good as looking at how other people build problems. So, and the fact that if you have, especially if you have Gentoo Linux, you have the whole package tree. You don't have to go to the net or anything else. you just go into use Portage and start browsing around and see how other people build e-builds, and you can read them because it's just bash script. If something goes wrong because things are sandboxed, it can be a little bit tricky to figure out why it doesn't work. Because when you compile it by hand, it works, and when you put it into Portage, it doesn't work. Well, there's a hope for that. Sandbox shell. It basically is a shell which you can ask to go into the very same environment that Portage works in. So basically you get a shell with the same restrictions, the same environment variables, and whatever that is used by the e-build itself. So you can run everything manually and see exactly what happens. Portage is really, really powerful and really well thought of. So, if an e-build grows too big and complex, you're probably doing something wrong. Rethink the whole thing. This is also what people will tell you on the mailing list if you have written an e-build and it's 10,000 lines and you ask about some silly question. They will first say, "That's fucking stupid. Start looking at some e-classes. Start looking at other e-builds because you're doing something wrong." An e-build does not have to be any longer than what you've seen today. There also are some complex ones. If you want to see something really complex, look at how XORG is handled. So they can be complex, but this is more the exception than the rule. So if it grows really big for something that should be simple, you're doing something wrong.
May I ask a small question?
Yeah.
I think debugging environment for shell script and sandbox shell is used for ordinary shell script.
It's used for debugging e-builds.
It's not a debugger, it just sticks you in that environment. So it's,
It's more like a simulator then.
Yeah.
yeah, use bash-x, that's the best you'll get debugging wise. Just spew some stuff.
Thank you.
And then, whenever you have problems, of course, ask on Gentoo forum and the mailing list. You can also, as I now learned today, there's quite a few Gentoo users here. You can probably also use TLUG. I would be very glad to help any who have problems with this because I love Portage, and I believe that any problem anyone in this room can have with Portage, it can probably be solved. So ask me if you have any problems. Man pages, other useful files. In the profile directory, there's these two very useful files. If you consider using use flags, go look at what use flags are used by the official packages. You can specify your own, but why not use something that is already used so your system stays like consistent? There's no reason to make another KDE flag. So, and you can see exactly what they are supposed to mean by looking at these two text files basically. Read the classes, they are scripts too. Other e-builds, we already covered that. And some links on the net. And some useful packages you might want to install. This one contains extra man pages for some of the most normally used e-classes. Sandbox shell, I already covered that. And Gentoo Kit contains some extra tools for playing around with Portage. Yeah.
And just what you didn't mention, looking at Bugzilla is a good thing too. Is people often put new e-builds there before they've made in Portage. You'll often find like when you're looking for something, or you've made an e-build, and then you might look at Bugzilla and find someone's already done it. So.
Yeah. Also, there's an e-build submitting how-to, and I'll post that to the list because Gentoo developers are typically overworked. So when a user wants to submit an e-build, we love it, and we'll help you out quite a bit as long as you follow the established guidelines. So that's what the e-build submitting how-to is. It's like the rules to follow to make developers like you and thus help you.
All right, any last questions? Nope. Well, thanks a lot.